R has in phase relationship, L has a lagging effect, and C has a leading effect. Please mind that whenever we are talking and using these terms, we are talking about angle or phase difference between voltage and current. Okay, so one thing more I could have written here also. Okay, I'll use a different color. So when we talk about equation for the resistor case, it was, for example, V is equal to Vm sin omega t. So current was also coming as I equal to Im sin omega t. So you can see the angle is omega t in both the places. So phase difference will be 0. Okay, when we talk about this inductor case, so if V is Vm sin of omega t, then my I is Im sin of omega t minus phi. So this is the lag part. Current is lagging by an angle phi. Okay. Whereas when we talk about a capacitor, if V is Vm sin omega t, we can write I as Im sin of omega t plus phi. Okay, so these were the differences, few of the differences that we saw in last class. Okay, so let's talk about what will happen if we'll connect a resistor and a inductor together. Okay, so students, this question has been asked in your exam. Why I am teaching you here is, like, since we have seen the individual behaviors, so we should also discuss about the combinational circuit also. Okay, so this one we have to see, and one more thing. Okay, so if I mark them as 1, 2 and 3, okay, so your first behavior when connected to okay, so this is a resistor we are talking about, this is capacitor, sorry, inductor, and suppose this is the behavior of capacitor. Okay, so what we are trying to do here is, okay, okay. So now this is my Vm and this is my Im. So you can see here they both are starting and ending at the same position. So there is no phase difference. Okay, so phase difference is 0. And here you can see if this is your Vm and this is your Im started late, that is this particular angle, that is phi. Okay, so here the phase difference is phi. And here we can say that I lags voltage. Okay, whereas if this is my Vm and this is my Im, so again there is a phase difference between this voltage and current. Let us again take this as phi. Okay, so here again phase difference is phi. Okay, but we can say here that here current leads voltage by an angle phi. Okay, so that's why we wrote here V equal to Vm sin of omega t, I is equal to Im sin of omega t. So angle is same, so phase difference is 0. Here this relationship if you want to prove. Okay, so you'll write V equal to Vm sine of omega t and I is equal to Im sine of omega t minus phi for lag. Similarly, for lead, if this is Vm sine omega t, so if current is leading, the angle should be omega t plus phi.
Sir, Im.
Yeah, hello. Okay, sorry. Okay, so this is the entire thing that you have to keep in mind before doing the combinational circuit. So now